Here is the video part 1 of the Unit 2B rational test review. In this first question, if Kieran is planning to bike 10 miles, that's our distance. And then we're writing an equation that gives his time t, so we want the equation to be t equals as a function of his rate. So r is going to be the variable that's changing, the independent variable. And we do know that distance equals rate times time. So if we divide both sides by r, we are going to see that distance divided by rate is equal to the time. So with the equation for this situation, the distance is 10 miles. It doesn't change. It's always just going to be 10 miles. But then there's no other factors, so just the rate is going to be dividing 10. So t equals 10 divided by r. You could also write t of r to show that it's a function of r. And then what is the meaning of t of 8 and what's its value? On the graph, t of 8 is about right here, where I made that purple dot. So t of 8, let's find the value first. T of 8 is going to be 10 divided by 8, which is 5/4 or 1.25. And so this means that the rate of 8 miles per hour will take 1.25 hours. To go the distance 10 miles. And it does make sense because the faster he travels, the less time it will take. So you can write that. The faster he travels, the less time it will take. Okay, so t of 0 is not on the graph because that's where the vertical asymptote is. That means that you're going 0 miles per hour will not get you there. Get Kieran there. So it does not make sense. T of 0 is 10 divided by 0, which is undefined. So as r gets closer and closer to 0, so as r is getting closer and closer to lower values, the time is going up. So the time increases as rate is slower. And just the opposite will happen. As the rate is increasing, as it's getting faster and faster, the time is going to decrease. Okay, so if C is a function that gives the average cost per book, C of X in dollars, when using an online store to print X copies of a self-published paperback book, the store charges $4 to print a copy, so per copy, as well as $120 for their setup fee. So C of X, we're writing an equation to represent the cost, which is C of X. The $120, that's just a one-time setup fee, but the $4 is per book, so we're going to multiply that by X. But then we're finding the average cost per book. So depending on how many books are printed, we're going to average that out between all the books. So we're going to divide that by X. We're going to use this same equation, but now to approximate the average cost per book when 50 books are printed, we're going to multiply this by 50, put in 50 for all your X values. And if you type that into a calculator correctly, you should get 320 divided by 50, which equals $6.40 per book when 50 are printed, and do the same thing but for 100 books. Since we're getting more books, it should be less. And if you type that in, you'll get $5.20. I don't know if I said that earlier the right way. So it is less per book if you do more books. If the author plans to charge $5 per book, how many should be printed to make at least some type of profit? So this is where C of x is now 5. So you want 5 equal to 120 plus 4x, and we're trying to solve for x. To solve for this, we're going to multiply by the least common denominator, or just x in this case. That will cancel out on the right side. But now we'll have 5x equals 120 plus 4x. If we subtract 4x on each side, we'll get x equals 120. So this is how much we'll break even. And so this is kind of just up in the interpretation. The author should print more than 120 books. But x equals 120 is the answer for being able to charge $5. And then the value of x equals 1/2 in this case, that means that we're printing half a book, which we can't do. So that doesn't make sense, but the value of it is going to be C of 1/2 equals 120 plus 4 times 1/2, all divided by 1/2, which equals 244. So the cost per book to print a half a book is going to be $244, but it doesn't make sense because you can't print just a half a book. Okay, and to rewrite these equations, J of x and K of x, in the form of Q of x plus R of x over B of x, we're going to do the box method, but it also asks to find the vertical asymptote and the domain. So I'm going to do those first, just to do that. Vertical asymptote is going to be found wherever our denominator is equal to 0. So the value that's going to make that equal to 0 is x equals -1. And you want to write that with an equal sign, where the domain is meaning that x cannot equal -1. So there's a difference between saying that the vertical asymptote, that's an equation. That's saying that the vertical asymptote is at that value, while the domain says we cannot have that value as an answer. So on the next one, we can't have -2 for x, so that's the domain, which means the vertical asymptote is there. So that's just the vertical asymptote and the domain for each of those. If we look at the box for J of x, we're dividing by x plus 1, so that's going to be on the side of your box. And you know that 3x squared has to come out of it. So in order to get 3x squared, x had to multiply by something, and that would have been 3x times x equals 3x squared. Multiply down, you'll get 3x. And those numbers, 3x plus 2x has to add to 5x in the equation. So to get that, we had to multiply by 2 and x, which meant that 2 times 1 equals 2. So Q of x is actually the 3x plus 2 part. So that's part of our answer. And then to find the remainder, we're going to do what it should have been. So -4 minus what it was, which was -2. And that is a -6. So that's the remainder, -6. And then we're going to divide that by what we originally divided by, which is x plus 1. And that's our answer with our vertical asymptote and domain. On the next one, we're going to do the same thing, box method. This one has one more term, so it's going to be just a little bit larger. And this time we're dividing by x plus 2. Okay, so 2x cubed has to start out because that's the first term in the polynomial. And so 2x squared had to multiply to make a 2x cubed with an x. And then 2x squared times 2 is going to give us a 4x squared. And we're going to add that because we need to be able to get to 3x squared. So we're going to add a negative x squared, which will then make it so that that'll be 3x squared. But we had to multiply by a negative x to get there. So then we'll multiply down, we'll get negative 2x. In order to get to positive 7x, we have to add 9x to get to positive 7x to that. And that means that we had to multiply by 9 and x to get to 9x. And then as we multiply down, we'll get to 18, which means that 2x squared minus x plus 9 is our q of x part. That's the stuff that divided nicely. To find the remainder, you're going to take negative 5, which is what it should have been, and subtract 18. And that's going to be a negative 23. So negative 23 is our remainder, and you're going to divide that by what it should have been divided by, which is x plus 2. Okay, on question 4, we have 2 competing sports teams. Suppliers sell footballs at different prices. Supplier A charges $85 in shipping and $2.59 per football, and B charges $50 to ship and $4.29 per football. So we're writing each equation for one for supplier A and one for supplier B. These are very similar because we want to find the average cost to the question that was before. We have 85 for the shipping of all of them and $2.59 per football. So we're going to times that by x, but then the average means we're going to divide it all by x. And then on the second one, it was $50 to ship, but now it's more expensive per football, $4.29 divided by x. So if you wanted to buy 40 football, plug in 40 to each of these. And if you plug that into a of x, you should get $4.72, I rounded that, per football. And then for B of 40, oopsie, I wrote that wrong, 429 times 40, divide that by 40, you get 554. So in this case, with only buying 40 footballs, supplier A would be the one to choose, but if you were to buy more footballs, supplier B might be the better route, or less footballs. It just depends on your total. And then Noah likes to go for boat rides along the river. In still water, the boat travels 8 kilometers per hour. In the river, it takes the same amount of time to go upstream 10 kilometers as it does to travel downstream 20. If the speed of the river is r, so this is either working for or against the boat, we're going to write expressions that for the time it takes to travel 10 kilometers upstream as it takes to travel 20 kilometers downstream. So when we're going upstream, that means that the current or the river is working against. So we can say that the time is equal, or the time is 10, which is the total kilometers that it went in that time. And then 8 minus whatever the river's current is or speed is. And then for downstream, time is equal to 20, which was its distance at that time, divided by 8 plus r. And the way we can get that is we know that time is equal to distance divided by rate from the first question. And so distance is based on how far it's going, And the rate is a combination of how far it can go in general, how fast it can go in general, along with the river speed. So if we want to find the actual R value, and we know that the time is equal, we can set these two expressions equal to each other. And on both sides, we're going to multiply by 8 minus R and 8 plus R. So that we have some factors cancel. Now we have 10 times 8 plus R equals 20 times 8 minus R. Distribute that so that we can get 80 plus 10R is equal to, 160 minus 20R. And just continue solving from there. I'm going to do both steps at once. So I get 30R equals 80. The rate equals 8/3 or 2.6 repeated kilometers per hour. So that's the speed of the river current. And that's going to end part 1 of this video.